Hello everyone, myself I'm Giri Prakash from Lovely Professional University. I am pursuing Bachelor of Technology in Electronics and Communication Engineering. So here we made an assignment for the rectification of a basic problem which is made in lots of IoT devices for converting the AC to DC. So we made an rectifier design which solves the basic problem in the normal and silicon diodes, which is that there is a lots of voltage drop over there, and here it needs to be an higher stability and the long-term usability. These are the problem statement we we have seen there. So for rectification of that, we made a circuit to get more stability and low voltage drops. For the basic understanding of rectifiers are commonly used for to convert alternate current to the direct current. And there are lots of rectifiers which we can use as from transformers, and we can use that as diodes also. For the voltage drop in circuits, so the voltage drop can impact on efficiency, and the benefit of low voltage drop is it can improve the efficiency and also consumes less power compared to normal diodes. For this for this problem, we replace the normal silicon diode with the Schottky diodes. Schottky diodes are normally used for the less forward voltage drop, and also the switching speeds between those is also high. And here the recovery time compared to the silicon diodes, these Schottky diodes are very good in that. For the comparison between Schottky diodes and the standard diodes, so these comparison may explain you a lot. That forward voltage drop, which is compared to normal diode, it's 1.15 percentage, and the switching speeds are also fast, and the reverse recovery time is also fast, and the Schottky diodes have high efficiency compared to the standard diodes. So here we made a circuit which explains how the forward voltage drop is actually working over there. So here this is the circuit for that. Here you can clearly note that we made that the Schottky diodes as in the bridge rectifier form, which gives the AC voltage as 5.13 volts, which converts thus to the output as 6.48 volts. Here the voltage will be normally high because of the uh, rectifier, the voltage will be high, and compared to the normal, it has the very less voltage drop, which is the positive for IoT devices normally used in solar plants for converting AC to DC, which is a potential way. And the testing results also, the voltage drop is 0.8 volt, which is very less, and the efficiency take over to 92%, which is the result we got to increase the efficiency over there. And for the future applications, we can use this as in a solar power systems, battery charging systems, and nowadays inductive charging is emerging more, so we can use this over there, and for the future energy efficiency. For the conclusions and takeaways, lower the voltage drop compared to the normal diodes, and the efficiency also higher, switching speeds also low, and the thermal performance is also good compared to the silicon diodes. It's okay guys, this is a project we have made, and let us discuss more on the comments to improve the efficiency. And also there is a lots of way to better this than the Schottky diodes by using those MOSFETs, which is a potential idea we will discuss in the comments.